Hello, welcome to Core User Group. My name is Mrinmoy Patacharji. I'm from Packet Core Cloud Mobility Management, and I'm going to show you an AIML model that we have built to perform management of AMF pools in Nokia deployments. So what happens is the AMFs in customer deployments are deployed in a pool. And the reason we deploy it in a pool so that they can provide redundancy. But what happens is sometimes these AMFs have to be taken out of service for maintenance, or sometimes there could be disaster scenarios which will take one or two AMFs out of the pool. And when that happens, what happens is that a lot of the users which were in the failed AMF, they have to be supported by the stable AMFs, and that can actually cause congestion. And that's where our AI solution comes in. The AI solution that we have is aware of what is going on in the AMF pool, and it also knows about the traffic pattern that each of the AMFs are handling, and the UV patterns, number of UVs, how they go up and down over the course of the day. These AI models know. So once the failed AMF gets recovered, then this AI model moves traffic from the stable AMFs to bring the entire pool back into rebalance. And when it does that, it maintains the pre-maintenance patterns, and it also prevents further congestion. So what are the benefits to our customers or operators? First of all, the models are trained, they learn the traffic pattern, and they are aware of the status of the peer AMFs. The model, when it's trained and when it learns how to forecast traffic pattern and UV pattern at least 36 hours into the future. And then it also knows the status of the peer. Secondly, what happens is with this knowledge, we can help making this redundancy optimization very, very intelligent. What happens is that the model knows how to offload the required number of UVs upon the recovery of the failed AMF, and it transfers all these UVs quickly, because if you didn't have this model and you had to depend on natural traffic rebalancing, sometimes it could take a week, or sometimes it could take even 2 weeks. But with this model, we can actually get this thing done very quickly. So the customer experience improvement is that they don't have to do any manual calculations. This is done all automatically by the model. And after everything is done, the model is able to maintain the pre-fault traffic pattern and avoid congestions. So how did we build the model? There are a variety of KPIs that goes into model training, and primarily the traffic mix and the pattern and the UV load pattern that goes into the model. And changes in KPI behavior over the course of days, weeks are presented to the model. So the model actually knows over the course of the week how these KPIs change. Over the weekend, there could be differences between weekdays and weekends. This model knows all of that. It's trained. And just to be careful and to make sure that we haven't overtuned a single model, we actually deploy and train multiple models. And the whole idea is that we want to make collective decisions. So we compare the outputs of the models, and we self-correct each other's errors, and then we make good decisions. And then when everything is done, automatic rebalance happens. And one of the key advantage is that after the failed AMF is recovered, the amount of time that is there in the pool with imbalanced traffic is reduced vastly by this model, because it knows that the peer came back up, and then automatically it's going to trigger the rebalance. We require the model to be very accurate. Its forecast has to be at least 95% or more. And the key takeaway here is that the deployed models can automatically rebalance the entire pool after the recovery of defaulted AMFs in 10 to 20 minutes. And compare that with natural rebalancing, which might take a week or more, or the operator has to actually hire an engineer and they have to do the manual calculations and then do the offloading, and then they have to actually observe how the offloading is going. But this model has everything built in. It also has a rate calculations built in, so that when it is doing the rebalancing, it knows, or it actually has things to figure out if it is putting the target AMF into congestion. And if it is doing that, if there is any indication, it backs off. So it's self-regulating. This whole model's performances or work is self-regulating. So I'll talk a little bit about the demo. Before going into the demo, I'll talk a little bit about the requirements for this set management model. It requires a machine learning intelligence service to be deployed in all the cloud mobility managers, or the AMFs, in the pool. And this model is very easy to enable, and it's already available within the CMM. So now if you look at the left-hand side, let's say this is your theoretical pool. You have 3 AMFs, carrying 5G traffic, and they are balanced, and that's what this cartoon shows us. And at some point, one of the AMFs are taken out of service for maintenance. And what happens is all their traffic goes to this AMF and that AMF, and their loading increases. So the chances of congestion increases because we are running one less AMF in the pool. Now, maintenance is over. This AMF is brought back into service. That's when our AI engine kicks in and then says, okay, we are aware of the situation of the pier. It's back. It is going to gracefully offload traffic from this AMF and that AMF, and basically make the entire pool stable again. So let me take you to our lab now. I'm gonna actually show you a recording. And the reason I am having to show you a recording is because, it's because the entire process takes, as I said, takes about 10 to 20 minutes, sometimes even 30 minutes. So it's, I have to shrink it down. So let me play this. So what we are showing here is, in this display, we have 2 CMMs in our demo. One is CMM 7, which is the view that you are seeing now, and one is CMM 17. That's the next view that you're going to see. In CMM 7, as you can see, there are about 1 million UEs that the CMM is supporting. And as you can see on the right-hand side, this is the connection, the connection that I talked about between the CMMs through the machine learning service. Now, I am showing you the view of CMM 17. Now, CMM 17 has about 820,000 UEs, a little bit less. And you see that the CMM is unlocked right now. It has not been taken out for any maintenance activity, and its connection with CMM 7 is up and running. Now I'm going to fast forward a little bit and show you, so right here, you can see that CMM 17 is going to go from an unlocked status to locked status. And as you can see, as soon as it went to locked status, all the UEs are gone. Now, where did they go? So these UEs are going to appear in CMM 7, its peer. And that's why we have these CMMs in a pool, because of redundancy. So I'm going to fast forward a little bit. And as you can see, CMM 7's UE count is now going up. It used to have about 1 million. Now it's 1,300,000. And as I fast forward this, you're going to see that this CMM 7 is going to end up with almost 2 million UEs. Okay. So now CMM 17 is still locked, and you can imagine that technicians are doing the maintenance work. Okay. And then at some point, very quickly, CMM 17 is going to get unlocked. I'm going to fast forward to that point. And as you can see, CMM 17 is unlocked now. And there is a little bit of a process that goes on here where we have to sync UV backup data. That's what's in progress right now. And as soon as the backup is complete, you see it here, backup is complete, you can see in this window that right here, CMM17 is telling CMM7 that, hey, offload my share of UVs so that we can bring this entire pool to rebalance. So that's what I have highlighted here. You can see there are some UVs that are trickling into CMM17, but that's very less. This is about 90,000, and it's going to just stay there. And then you have about 700,000 to 800,000 UVs to be moved back to CMM17. So this process goes on. Now I'm showing you the machine learning service on the CMM7. And right here, I'm going to highlight the total number of UVs the AIML model on CMM7 is going to say that we are going to offload. And it's going to be around 820,000 UVs. So you can see it here. And as you can see right now, the number of UVs on CMM7 are slowly beginning to go down because it has actually started the offload process. You can see on this window here, the offload process, AIML-driven offload process is in progress. So I am going to fast forward a little bit, and you can see CMM7 is saying offloading is complete. So this is in CMM17. And fast forward a little bit more, actually it's still running. Takes some time. Around here, it is complete. Right here, it's complete. And you can see in the master.log in CMM7, it says AI-driven UV offloading is complete. And as you can see, in CMM7, we ended up with about 1 million UVs. That's what we had. The whole process is complete. And then if we go to CMM17, you're going to end up with about 1 million UVs. Okay, so let me just get out of here and go back to my slide set, because I wanted to show you pictorially how this offloading, what's the result of this offloading? Because we went through this whole offloading process, rebalance process in the lab. So here's the result. So this is CMM17. This is the result of CMM17. We have actually in this demo, we have taken CMM17 down for maintenance twice. And this up and down pattern is the actual traffic pattern that plays out in a customer deployment. You have the busy hours of the day, you have the non-busy hours of the day, and just for demo purpose, we have shrunk the day. As you can see, these are the places where CMM17 was down for maintenance. And then as soon as CMM17 was brought back into service, you can see within the green circles, rebalance was done in about less than 6 minutes. And the main point is that the traffic cadence was preserved on CMM17. Same story in CMM7. You are going to see the spikes here because the spikes show you the times when CMM17 was down for maintenance. And each time CMM17 was brought back up, appropriate number of UVs with the proper traffic mix were offloaded. And the end result, as you can see, once the system becomes stable, we basically preserved with a high accuracy the traffic cadence of this entire pool. So the key takeaways, this model is integrated in the CMM since November of 2024. And the advantage is that it is AI assisted. So it's intelligent and is aware of the situation, what's going on, of the peers and the network characteristics. And biggest advantage is it can actually automatically rebalance the AMF pool, avoid congestion, limit the time for which the pool runs imbalanced, and reduces the chances of further outage. Thank you very much.